Alright. Hello everyone, I'm Garner. Today I'm going to be talking to you about horizontal hydrofracking for natural shale gas. It sounds pretty specific, a little bit detailed. I'll get through a lot of the details. It's going to be a lot of information and we're kind of running short on time, so I'm going to try and stick really closely to my time crunch. So first of all, I need to tell you a little bit about natural gas. It's become a major energy source and potential for our future in the United States. The U.S. has about 2,200 trillion cubic feet of estimated total natural reserves for shale gas. We know for sure that we can access 273 trillion cubic feet of this. And just to kind of put this in perspective, every year we're using about 24 trillion of that. So if you do the math, that's about 100 years worth of reserves that we have in natural gas. Where do we use this? We're using it mostly in energy production, and about 20% of our energy in the United States is coming from natural gas. So that kind of sets up an importance, just how prevalent it is in our society. So we need to ask ourselves, where is this gas? Specifically, it's in a lot of the shales across the United States. You have specifically the Barnett Shale, you have the Marcellus Shale, which is a huge one. They describe it as an ocean of natural gas, and literally it is. In the United States, we have 5 times the volume of Lake Superior in natural gas available to us. And then all of this shale gas is underground in the shale rocks. So this is our aquifer up here. We have our wellhead. The well is not exactly to scale, but the depths are. And you have to go all the way down to anywhere between 5,000 to 8,000 feet, and then you start coming across and you break the shale down here to release the gas. So, I'm going to talk to you today about the facts and then the controversy surrounding shale gases extraction via hydrofracking in a horizontal method. It's kind of an unconventional method, but first I'm going to talk about the extraction process. Then I'm going to talk about the placement of drilling pads. And then I'm going to talk about the risks of hydrofracking followed by the benefits. I really think it's important not to lose track of the benefits. And hopefully by the end I hope to inform you of just what hydrofracking is doing and give you a little bit more information so you can decide for yourself whether it's worth it. So a history of unconventional drilling. We need a few things. Hydrofracking started in the 1940s, but it really became unconventional in the 1980s when directional drilling came out. That was the ability to go down and then start going sideways. That was followed by a friction reducer for water. It sounds kind of crazy, but you need to reduce the friction in water and the viscosity in order for the pressures to get as high as they do. And then we needed to start developing multi-well pads. That's the ability to drill multiple wells on a single pad instead of just drilling straight down everywhere you can. And then finally we need to start using large amounts of fracking fluid, and that kind of came along with all of this. So the process of hydrofracking, we're going to go back to this graphic. Basically, they start out with this. They drill through the aquifer, and then they put a steel casing along the way inside of a cement barrier. And it goes down to about 1,000 feet, and then they drill the rest out. And when they get to the level they want, they actually are able to turn the drill bit now. It's kind of a strange motor system that they have. And they guide it all by monitoring electromagnetics, which is kind of cool because they can see exactly where their drill is at underground. And then when they go across, they can go up to 2 miles in any direction from the well pad, which is really crazy. And then what they'll do is they'll blast the end section here, they'll pump fracking fluid down, they'll extract the natural gas after it's been propped open so it can flow back into the pipe, bring it back up, and then they come back 2 months later and they can blast the next section, and it's called refracking. They can frack a well up to 18 times. So you can continue to get more value out of every well. So here's some general facts about it. What goes into the well? You get 3 to 5 million gallons of water. That is a lot of water. It comes in 8,000 gallon trucks, and you just have hundreds of them coming in and day out. So it's a heavy industrialization. And then there's the fracking fluid. This is purportedly the worst part of the hydrofracking process because people don't know what's in it. There's been about 596 identified chemicals over the entire life of hydrofracking that's been used. But really, that's not on all sites. That's really important to understand. This is the basics of what you need to hydrofrack. You need a proppant to hold up when you frack it, when you break open the rocks. You need a sand to hold and open the cracks that way all the gas can escape. You need biocides to get rid of the bacteria that are down there. A fluid loss additive, I'm not exactly sure what that is. I wasn't able to dig that up. Anti-corrosives to protect the drill bit. Friction reducers for the water, and then an acid just to keep things clean down underground. Then you need a lot of pressure. They have a lot of pressure to break all that rock apart. It's up to 10,000 psi at the bottom of the well. And overall, companies spend about $4.5 million of money on each well. What comes out? get a lot of wastewater. All this stuff comes back out as one giant mix. And then you get a lot of airborne emissions. You get some VOCs, some methane, some other interesting chemicals that come out, because there's a lot of stuff that's down there that we don't really have a whole lot of control over. And that affects our air quality. Then we have some radioactive materials. There's some radium down there, 232, uranium a little bit. You get some radon. Some radioactive materials. This needs to be treated, and that's done after the post-production. And then, over the lifetime of a well, they're expected to get 4.2 billion cubic feet of gas on average from a single well. And for the companies, that means $16 million worth of money. And if you're a lone landowner, you get royalty rights, which means you can typically get up to 20 to 25% of the money, of the gas, that was extracted from under your property. That's a lot of money. So well locations, I'm going to start speeding it up a little bit more. This is high density placement. This is about one pad for every 40 acres. This is a very unusual, usually it's about one for every 80 or every 120 acres. This is why I asked you, would you rather have a windmill in your backyard, or would you rather have a well? Because it could happen. Now to show you how exactly it works, each of these dots is a well pad, and each of these lines is a well line that was drilled out laterally. This is the Dallas-Fort Worth Airport. They made a lot of money on this because they were able to drill out all this natural gas. It's something like $10,000 an acre for signing bonus, and then the royalty rights were like 25%. It was a lot of money, it brings in a lot of stuff. Some of the risks of hydrofracking, people, if you have a failure in your well cap, people have been known to have water that can basically explode. That's some guy lighting his faucet on fire because methane is leached into his water supply. Once your water supply is contaminated, it's done. You pretty much have to cap your well. Also, you have the airborne chemicals that I talked about. So basically this is an evaporation pond where they bring out all the water to, and sometimes they just evaporate a lot of the water just to get rid of it, and sometimes other stuff gets evaporated with that. But one of the big things that happens, specifically for the methane, to give you a better idea, is that it'll come up the side of the well pipe right here and eventually make its way into the water. And there's a bunch of other ways. Basically any way that you can get a perforation, you can get migration through the well path, through the well head, it's going to cause issues. Benefits, landowners make money. If you're a landowner, you can get a lot of money just from signing, and then you can get more money from the royalties. Also, it creates jobs. In Pennsylvania alone, the Marcellus Shale is expected to make 110,000 jobs over its lifetime. It's a lot of jobs for a lot of people in our tough economy, and a lot of people want that. But the biggest thing that people want to do, they want to get rid of our foreign dependence on oil. The thing is that vehicles are what's using a lot of our oil. Unless you have city buses, you can't really use natural gas for that unless we change our automobiles. However, this is really good for industry because that's where we use most of our natural gas, and it'll eliminate a lot of coal and other things that we use. So like I said, this is creating a lot of controversy. I hope I've given you a little bit more information so you can dig deeper for yourselves and you can understand for yourselves what's going on. Neighbors are divided because some want to take the risk and make the money, others don't want to take the risk of contaminating their water supply or having dirty air. It's dividing a lot of communities. I hope I've provided you a little bit more information. If you have any questions, I'll take them now. Yes?
110,000 jobs. Over what span is that, and are those jobs directly related to the drilling itself, or are they the multiplier effect of having more money in the community so that people buy food in restaurants and that sort of thing?
It's a result of the entire gas industry that we're looking at it, the gas industry development in the area. So these jobs are like refining processes, the process of getting the gas out to the other places where it needs to go, building of pipelines, just creating the infrastructure of natural gas. So that's where the jobs are coming from. And we're looking at about, I think, a 50-year period that all these jobs are going to be over. So many of these are going to be lifelong career type things, and someone can be working in this industry for quite some time. Does that answer your question? Okay. Anyone else? I know I kind of bombarded you guys with information. Alrighty, well if you have any more questions, feel free to ask me after. Thank you.